Hey, welcome everyone. Myself, Richard Kerslake and Jeff Cooper. We'd like to sort of chat to you. There's Jeff for the next, I guess, 20 minutes or so about some of the work we've been doing within the FIDO Alliance to address the challenge in the industry of onboarding. And again, we'll start really on why that matters. And I guess the obvious question, why should anyone care about onboarding? Well, we often talk about all the great things IoT can do, what we can do with the data once we have it. But obviously, before any of that can happen, the devices themselves need to be connected to the management platform. And today, that's largely done in a manual fashion. A tech is sent out, and typically the data we've been seeing is each onboarding can take 20 minutes. I've heard of several hours even for that. So one, it's expensive. Two, obviously, it's insecure. So question is, how do you address that? What can we do to really remove that friction? What's interesting about the world of IoT is that it's massively fragmented. So if we were just talking about onboarding PCs, then clearly they're fairly homogeneous. You could come up with a solution that would probably work well for all PCs. When you get to IoT devices, you've got different hardware, different operating systems. Some have displays, some don't have displays. Some have wired networks, some have wireless. So whatever solution you come up with has to be extremely flexible. The way that we've worked to address that is through a group which some of you may know called the FIDO Alliance. And just to kind of give a little bit of background for those of you that don't know it, it's an organization that was set up, an alliance industry group, really to focus on removing the need for passwords. As you can see here, they want to solve the password problem. Most of the work they originally did was, and some of you may have seen it, keys for secure access on email and the like. And so for them, as an organization, moving into the IoT space was a fairly natural transition. And as you can see from the membership, a lot of the key folk that you need to make this kind of a specification happen, whether it's cloud providers, whether it's semiconductor companies, whether it's security companies, they were already members of FIDO. So it was a very natural group to drive an initiative such as this. Tiny bit of history before we get into the technicalities of how FDO works. The effort was kicked off as a FIDO working group on IoT in the summer of 2019. The first thing we did was really pull together use cases from a wide variety of companies that really sort of said, here's the problem that we think needs to be solved. And from those were distilled down to a number of use cases. And from that, we could kind of move forward. And at the end of 2019, one of the big decisions that was made by the working group was, do we kind of start with a white sheet of paper, or do we try and reuse the technology that's close to something that could meet the needs of the use cases? And the decision was that Intel had created something called FIDO Device Onboard, FDO, and the decision made by the organization was that we would leverage FDO as the basis for FDO. So what FDO is, it's really built upon FDO, but many new ideas, concepts, new technologies that hadn't existed when FDO was originally imagined were kind of added in. If I kind of cut to where we are today, you can see on the right-hand side that in April, a specification was issued by the FIDO Alliance, FDO. And as you can see from the editors, we had a very good representation, I think, both on the semiconductor side and on the cloud side. And Jeff, who's obviously here today, was one of the key editors.
And we did actually do our first cross-company Interop yesterday. And it was terrible, but it's moving along.
Yeah. And that's the purpose of an Interop, right? So right. Very quickly, what's the whole concept here? It's kind of simple. You've got an IoT device. It's been manufactured. It's in a box. You ship it to the point of installation. Someone who's semi-skilled basically connects it to the network, powers it up, and then the rest of the onboarding happens in a completely automated and secure fashion. So what are the benefits? Clearly, it needs to be zero touch for the person doing the installation. the goal is to reduce costs, as we talked about. Today, you're sending a technician out to do that work. It's got to be fast, got to be secure. It needs to run on really a wide variety of processors. And so about a couple of years back, we really reached out to ARM to say, look, do you agree this is something in the industry that needs to be solved? And so they've been very much, as you saw, an active member of the FIDO Alliance. And we've demonstrated this technology on anything from a small microcontroller up to a server class processor. On-prem, off-prem, I heard on the previous discussion about what runs in the cloud, what runs locally. In this kind of a problem statement, you need something that's highly flexible. It needs to be able to run on-site, if that's your use case, or it can run in the cloud. And with FDO, both are appropriate. Late binding, I'm going to touch on in a moment, but it's a very important element of why we believe FDO is a good solution for the industry. Up until now, everything I've talked about is really about the specification, the technology. We haven't talked about how it gets implemented. And often with a standards body, you get a piece of paper and you say, congratulations, here's the specification. And then some soul, poor soul has to go off and implement it. Well, we made the decision that we wanted to have a development of an open source software project in tandem, so that customers and partners would have not only the specification, but they would also have a software implementation. And that's what we've been doing with Linux Foundation Edge, to really kind of deliver a complete package. I talked about the supply chain, and maybe I'll spend just a moment here. There are other technologies in the industry today that say, hey, we've solved this onboarding problem. We think we've nailed it. But probably one of the biggest limitations, probably two major limitations. One, of course, they're not really standards. They're usually proprietary, linked to one vendor, linked to one company. That's kind of number one. But number two is they work by assuming at the point of manufacture, you know who the end customer is going to be. And not only do you need to know which cloud they're going to be on, but you need to know who they are. So if Jasper wants 100 devices, I need to build Jasper 100 devices. So he sends me an order. I say, thanks, Jasper. I'll get our ODM to go build them. The devices flow through the production line, and X months later, here you go. And obviously what you're seeing there is a massive amount of friction and cost in that supply chain. With FDO, it doesn't work that way. Tom says he wants 100 devices. We say, great, go to your distributor, go to your VAR, take them straight out of inventory. Why? Because every one of those devices can be configured at the point of installation to onboard to a particular platform. So if Tom has his platform, no problem. He can buy exactly the same device as I can, as Mark, or anyone else. So that's really one of the big value adds. I'll kind of show one more slide and maybe we'll take a little pause for questions. One of the things we kind of had to decide fairly on was, what was the center of gravity? Were we trying to solve every onboarding problem? Were we trying to solve consumer problems, industrial problems? And really where FDO brings the biggest value is it industrial and enterprise applications, where we have what we call the untrusted model. In other words, the person that's installing the device, you may trust them to be in the building, you may trust them as an employee, but that doesn't mean you really want to trust them with all the credentials of devices on your network. You really want them out of the equation with respect to security. You also want to be able to have, as I said, this flexibility to work with any platform. You need this ability to handle the supply chain, distributors, VARs. And obviously at the end of it, people, they sell things, right? You installed it, it sat there for 4 years, and then you made a decision you can deploy it to another factory, or maybe you sold it. And all of those things needed to be factored into the solution. So I'm going to take a little breather now. Jeff's going to walk us through how it works. But any questions about the problem statement up until that point? If not.
So Richard, if I can just clarify, I think I understand, but I'm just making sure that I do. So what you're saying is that at the moment when you build a device, you have to know everything about it. It's a proprietary supply chain, and you want to move that to an industry standard so that we can all interoperate with each other's kind of interoperate with on this standard. But if I get it right, this is very early stage, and you were saying you just did some interoperability testing, but it didn't go so well. So this is still a little way away. This isn't actually shipping product.
So where we are on the process, as you'll see in a minute, the first thing you do is obviously a specification, and then you execute the software. The event yesterday was the first FIDO sponsored event where people came with their equipment to say, let's give this a go. So what we're seeing now is you're seeing vendors, whether they're software vendors, hardware vendors, actually kind of bring up their first products that are FDO compliant. And so clearly, the very nature of an interop, especially this one, which was kind of a pre-interop, is just to kind of shape things out and let people move ahead. I would say that it is moving quickly simply because, one, there's a vacuum to fill here, and two, the code that we're using is based very closely on the SDO code that we've developed over the last few years. So I think it's going to mature very quickly. It's not that we've just started with a white sheet of paper and say, hey, how should we solve this problem? FDO in many ways isn't FDO 1.0, it's FDO 2.0. So I think, as you'll see in a moment, the real focus in 2021-22 now is that wide-scale deployment as people kind of come on board in the ecosystem. But, as you've seen, first event was yesterday, a few bumps in the road's probably not too surprising.
Oh yeah, and it's not a criticism at all. In fact, it's a compliment. I'm very happy that you're open and honest and saying, hey, we got together and we learned a whole bunch of stuff. We weren't expecting it to go perfectly. This is how the process works. I appreciate the honesty. Actually, it's refreshing to have that level of transparency. And honestly, I think that means that we can all trust in this, and the fact that you're being this transparent shows us how this is going to work, and we can all trust that, yes, it is actually going to work and be quite good. So it's great.
Thank you. Thanks.
I have one more question about this. Are you guys actually planning on having gateway devices for the older equipment? When you start talking about some of the industrial locations, they have very old equipment. So were you planning on having FDO compliant gateways that they could use to onboard those older pieces of equipment, speaking the older pieces of equipment's language instead of something new?
So I'll kind of half answer that. Maybe Jeff, you want to jump in. Obviously, if something's onboarded and it's working perfectly well, no need to mess with it. If it's literally in a factory, it's onboarded, it's doing its job, leave well alone. If somebody says, hey, here's a product I designed 10 years ago before FDO even existed, can I make this product work with FDO? The answer is, it depends. But often, if it's a Linux machine or it runs a high-level operating system, very likely the answer is yes. And in fact, we've kind of did a proof of the pudding. And if you go to our website, you'll see some of the work we did with British Telecom, where they had some security cameras that were 9-10 years old. And we were still able to basically add FDO into them. So if a customer says, look, I've already designed these products 4 years ago, am I shut out of this FDO thing? The answer is probably not. You will have to make some trade-offs on security about, roots of trust. But there's a good chance, if you want to, you can take that product and FDO enable it.
Very interesting. Thank you.
Jeff?
Okay. So if we start at the device manufacturer up on the left-hand side of the diagram, we're building the board level product. And as you build the board level product, you would embed some credentials into it. And so there's in the normal situation, you can imagine there's a root of trust key, there are some other kinds of incidental credentials. In the case of FDO, if we can build one more, Richard, in the case of FDO, there are credentials that go in the device, and then there are credentials that go alongside the device. And these are cryptographically linked. So there's something called an ownership voucher that goes through the supply chain. And that would be something that you would get, for example, with the paperwork for the device. It would go in the administrative side. The device itself, the idea is that it goes into a box and it doesn't have to be opened again until it gets to the target environment where it's going to be onboarded. You don't have to open it up, install a little bit, open it up, install a little bit. You can ship it all the way through. Now, the ownership voucher gets sent to the target cloud that is going to onboard. And when I say cloud, without loss of generality, this could all be inside of a closed network. Think of it as the server that's going to onboard. Now, the target cloud will take the ownership voucher, and we have another server in there. This is like a DNS. It's like a name lookup. It's really saying, well, when the device wakes up, it's going to need to figure out who is the prospective owner for this device, and it'll actually contact the rendezvous server. So the next step is actually that the device gets shipped over to its final location, gets powered on. So this could happen a day or two later. And then when the device gets powered on, the next thing that it will do is it will actually contact the rendezvous server to discover who the owner is. And this is a pure discovery. This is not an authentication. And then the next step is that the device will actually use its root of trust key to authenticate to the cloud. And the cloud will actually use the ownership voucher in a new form of authentication into the IoT device. So you get two-way authentication and you'll build a channel. And then over that channel, you can download all of the ingredients that you need. There's no limit to how many keys you would download to what kind of keys. So you can download keys, tokens, you can request software upgrades, etc. And you can do that to the point where the device comes up and it's now running in its application on your device management system in service automatically. So if you think about it, we actually did this going from the factory, the device was put in a box, and then it went all the way to the final location. There were basic networking and connectivity, attached to the wall kind of issues that were handled by an installer person, and then the installer person turned it on. That's the only interaction that the installer has with the device. And then the device installs itself. So that's basically what we're trying to do with FDO.
Thanks, Chip. Questions?
Yeah, I have a quick question. So does this system, is it built around also doing firmware validation? So again, when we're talking about supply chain, when it's coming out of the factory, somewhere in the middle, someone could do something to the firmware. Does this have that sort of validation built into it?
So it can be layered on top of it. So what we did is we designed a general purpose onboarding mechanism that comes in once you have the encrypted channel. So you have enough trust to build an encrypted channel. Then over that encrypted channel, you can actually run arbitrary types of commands. So if someone wants to build a module into their device, that an FDO module that says, I'd like to, for example, get my TPM PCRs, then you could go and verify the TPM PCRs, and you could use that to do verification on the platform. And we do have people who are doing that.
Perfect, thank you.
Yeah, Tori, a question. It might be a bit thorny and might be tricky to answer at the moment. On that pathway of if this works as advertised, it'll be awesome. If it doesn't work quite smoothly, I'm interested in how the troubleshooting will work, particularly as you've mentioned that this is going to have people who are not especially trained in this stuff because we hope that they don't need to be. So if something goes wrong at install time, what do you imagine is the troubleshooting process going to look like?
Well, I imagine that there will be tools that will handle the basic troubleshooting of the basic network problems. So we don't have connectivity to the target cloud or something very basic about the device, or device is not attached to the network. And then beyond that, I think that the devices will probably be pretty reliable once you actually get the data to flow through. And if not, I think people will return them to the people they bought them from. And this is actually the basis of the ownership voucher trust, which is that you get the ownership voucher through the supply chain. And if the device doesn't onboard, you return it back to the supply chain. It's just as you would if you got the device, you took it out and you found that there was a tractor trailer that had run over the device and it was a piece of garbage, right? So the same. So you're using that same level of commitment to the supply chain to do the onboarding. And so that's the final answer to what you would do. Yeah.
So this is just a quick whiz through of, as you realize, FDO is not one piece of software, it's multiple pieces of software. And if you look at this picture, you'll see, number one, there's a piece of software that's the client. It actually runs on your box, whether it's Intel or it's ARM or it's some other processor with or without TPM. Two, there's a tool called the manufacturing tool that we provide to ODMs and OEMs. It allows them to place the appropriate credentials in the device. It creates that ownership voucher. Three, you heard about the rendezvous server, which is actually doing redirect. Again, we provide that code exists in open source. Companies are now starting to plan their bring up of rendezvous servers. There's ones such as Login ID that are already up and running, and some of the other names are working on that right now. There's code that sits within the cloud, the ownership, and then last but not least, you've got this reseller tool which can extend the ownership voucher through the supply chain. I mentioned earlier that the code is production quality and it's now available in Linux Foundation Edge, and you notice the spec was released in April and the actual production code came out in August. And the reason why is we got an agreement between FIDO and open source community that we would actually give early versions of the specification so that the development could continue in parallel. This is, I think, touches on a little bit what we said earlier. We're working now within FIDO. It already has a certification program, but we're really leveraging a lot of that now to do different levels of certification, whether it's based on a questionnaire, whether it's documentation and verified by a third party, or whether it's a full lab verification. So levels of certification and security. And again, you heard very much from Jeff about the Interop work that's kicking off now. There's another event set for Taiwan in January, so we're making this a worldwide event. I know we only have a couple of minutes left.
So I have one last question for you, or another question for you. Once if I'm going to deploy that device in a non-network connected area, in other words, it's connected to its own private network, but nowhere else, I may want to do that for a cooling system controller or electrical, some other industrial controller to keep it off the network, but I still need to be able to manage it, et cetera.
So it's the protocol is specifically designed to allow that to happen. And the idea is that you can bring the credentials on the USB stick into the closed network. And then when the device comes up, your network environment will have enough information for the device to find your local servers and to onboard itself within a closed network. So we thought of closed networks, enterprise networks, internet, open internet, and we think all of those are required. And we do routinely onboard in closed networks.
Yeah, and it's a low compute task, so actually you don't really need to run anything particularly sophisticated to the rendezvous server type performance. So you can absolutely run it in an industrial environment where nothing can leave the building. This is a little sideways step, which is to say, now we have a standard. Is that it? And the answer is no. I mean, you can innovate like any standard on top. So we wanted to kind of show you something the Intel's been working on, which we call bare metal on board. And it takes it to the kind of next level. It says, what happens if I want to ship an empty box? Literally something that has pretty much nothing on board. And I ship it directly to where I need it. And all of the software that I need can get remotely and securely deployed onto that box. And that's what we can deliver now with BMO. So maybe, Jeff, do you want to spend a minute just kind of whistling through that?
So what you'd do is you'd have a secure area of your, say you've got an empty building and you're installing equipment in the building. You'd have a secure area of the building where you'd unbox the equipment, and you'd use the Edge Software Provisioner, which is actually a Pixie boot environment. So it's a trusted network. And you'd use that to get FDO installed. And so that would be one key press. So you do one key press and now your device is installed. And actually the device management system already has the ownership voucher at that point. Then you take the device and you can bring it over. You no longer need to be on a trusted network. You can have an open construction site with people milling around everywhere. You plug in the device and the devices will onboard. So it's an opportunity to take bare metal devices, even all the way up to servers, and to install them in a larger site environment without necessarily having to have manufacturing support.
So really just to finish up, goals for the rest of this year and next year for FIDO. One is driving this adoption, getting people across the whole ecosystem, be it cloud silicon, ODMs, OEMs. Two, working on the certification program. And obviously, we're looking at kind of what comes next. Should we look at partnering to address maybe even consumer type centric applications where the ownership voucher mechanism might be less appropriate, but the late binding is really important. You still may have multiple ecosystems in your home and you still want that late binding, but you may not want the complexity associated with an ownership voucher, especially as you may say, well, look, I'm a trusted installer. It's my home. Why wouldn't I be?